Hi everybody, here is a video that explains the summary of what Unit 7, Lesson 6, and Lesson 7 is trying to get you to understand. Up to this point, we only worked with bases that were 10. So base means our big number here. And we're multiplying, we're dividing, we're taking powers, and we're looking at negative exponents. If you don't get anything from this video, get that even when our base changes, we are still doing the same thing with those exponents. Your handout's going to explain why. The table that you go through, just like before we left for this break, it'll tell you the why, but this is the main idea. So here is a problem that we've seen before in class. We are multiplying powers because of this dot here in the middle. When we multiply, we want to add our exponents. So our answer here would be 10 to the 6th power. That's when we have a single power of 10. We've combined using what we know about our exponents. We add them together. Now, the big question in this lesson, or in both of these lessons, is what if my base, or this big number, isn't 10? What if it's 3? We can do the exact same thing. Even when these bases change, so long as they're the same base, which they still are in these two lessons, we still just add up our exponents. So our answer here would be 3 to the 4 plus 2, or 3 to the 6th power. Nothing is changing except what our base is. This also works when we have negative exponents. So say we had 5 to the negative 4 times 5 to the positive 8. I'm still multiplying. That dot tells me I'm multiplying powers, so I need to add. I'm adding these up. 5 to the negative 4. I have to be careful with these negatives, though. I might want to put parentheses around them so I don't forget it is a negative number I'm working with. But I can still add that up just like anything else. Negative 4 plus a positive 8 is going to be positive 4. And that would be my answer, 5 to the 4th power. So we've seen some multiplying powers, but we haven't seen division yet. Again, works the same way as when we are using powers of 10. So say we have 4 to the 5th power divided by 4 to the 3rd power. When we were working with powers of 10, we subtracted our exponents. I'm going to do the same thing here, even though our base is 4. This division symbol, remember, it looks kind of like a subtraction sign. That's how I remember that I want to subtract those exponents. So I have 4 to the 5 minus 3. I always want to take my numerator number first and then subtract what my denominator number is. It's going to be 4. 5 minus 3 is 2. 4 to the 2nd power. Looking the same as what we did with powers of 10. If you've forgotten these power rules that we learned, or these exponent rules before the break, on every single instructional, assignment, one of the uploads, one of the links you can go to is the exponent rules. It's a slideshow that has all the rules we've learned on it. Might be a good idea, especially if you don't have your notes at home, to remember when you divide, it'll tell you subtract. When you multiply, you add those exponents together. Another thing that both of these handouts will mention or go into is even when we have numbers less than 1, say like 1/3 to the 5th power times 1/3, maybe to the 2nd power. Even when we have fractions, works the same exact way. We still want to add up these exponents because we're multiplying these powers together. So I would have 1/3 to the 5 plus 2, or 1/3 to the 7th power. It works the same way. Finally, I want to at least mention something about taking a base to a negative exponent. I know that was the last thing we did before we were out for the break, and a lot of you were confused. So what we learned before the break was, say, 10 to the negative 3. If I ask you to make this a positive power, or have a positive exponent, what we did was we took it and flipped it. We found the reciprocal, is that math vocab word? We flipped it upside down to make it a fraction. So I would take 1 and then 10 to the third. But notice when we do this, that is how our exponent becomes positive. When we flip it in that fraction form, when it's taken the reciprocal of it, this negative is now positive. Now I'm not explaining the y right here. We went into really good detail with that before the break, but this is the rule that you could memorize for other problems. Now again, this is base 10, which is what we're used to, but in these two lessons, you're not going to see any 10s. You might see, for instance, a 6 to the negative 7th power. If I wanted you to write this as a single positive exponent, still take that reciprocal, we flip it over, we put it as a fraction, 1 over 6 to the positive 7th. And where I'm getting this one, when I say that we're flipping it, any whole number period can be divided by 1, and it doesn't change the value at all. Dividing by 1 does not change what your number is. So if I put a little divide by 1, I still have 6 to the negative 7th power, but this kind of shows you why, or how I'm getting that flipped fraction and the 1's on top. Some of you might be thinking, where'd that 1 come from? If you have any other questions, please look at that video resource doc. There's some other videos going through the handout and other practice that you can do. Again, feel free, email me, message me if any part of this is not making sense to you. Thank you.